Hello! We call our video about carboxylic acids. Today, I'm going to talk to you about functional groups. Now, a carboxylic acid here is one out of many types of different functional groups, being indicated by R, wait until I symbol my molecule, COOH, like this. If you want, I can draw it for you. Remember about carboxylic acids? Well, here it is. In case you don't. RCOH, to say the general formula. I'll circle all the functional groups from now onwards. Next, what about alcohols? They are quite simple molecules. As you can see here, consisting, the functional group is simply an OH. So, the general formula is simply ROH, like this. Videos. Which makes it very simple. Methanol is the simplest alcohol, as alcohols have to be organic. Carbon atoms. Next, aldehydes and ketones. Now, yes, an aldehyde here has a hydrogen attached at the end of a carbon chain. Ketones are similar, except it's in the middle of a carbon chain, as if there were two carbon chains attached to it. In the centre is a carbonyl group, the defining characteristic of aldehydes and ketones, CO. Yes, by the way, that is the same group as carbon monoxide. And second to last of our basic functional groups here, we have an amine. Quite common and quite simple. Like the equivalent of alcohol but with a nitrogen actually close to methyl, as there's more than one here. In H2, because nitrogen has 3 bonds connected to it, 5 friends electrons. So you can have 3 or 5. So yes, it's in H2. As you can see here. The amine group in H2 is connected to a carbon chain, as always in functional groups. And the last of our basic functional groups we conclude with the nitrile. Right? RCN. And yes, that is the same functional group as cyanide. CN with a triple bond. Aldehydes and ketones, recall, are similar. Recall, have the same as carbon monoxide. So they can be seen as the base members of these classes. Although the simplest here, of course, would simply be hydrogen cyanide. The triple bond makes the bonds balance rather perfectly. Next, for the more complicated functional groups, which have 2 substituents and require modifying one of ours. This one. First, the ether, which is an oxygen bridging the gap between 2 carbon chains. Simplest being dimethyl ether. Let me draw it up. Not entirely too difficult. Just like a dye substitutes alcohol. An extra substitution. So substituted alcohol. Basically. Next. And this concludes our functional groups. Wait when I assemble the molecule. Esters. Which has a carboxylic acid group, as you can see here, bridging the two carbon chains. Actually, it isn't a true carboxylic acid because there's a single hydrogen there. That's it. It's a bridging form, as if you could call it that. So, I should forward, as usual. Right, I forgot to highlight the groups. I'm doing that, I'll do that. I'm doing it right now. And that, everybody, concludes our lesson on functional groups.
Well, would you like to just give a quick overview of the stuff on the boards again, of what you covered?
These are all functional groups: carboxylic acids, alcohols, aldehydes, ketones, amines, nitriles, ethers, and esters. I call these base functional groups because they have only one substitution. Hence, ketones I could classify as a secondary one. And then there's multiple substitutions.
Cool.
Hope you enjoyed. Nitrile, amine, aldehyde, ketone, ester, alcohol, carboxylic acid, ester. I got those a bit muddled up. I mean, this is meant to be an ether, not an ester. This is So goodbye and hope you enjoy.